Welcome to the Basic Calculus Vocabulary Day 2. Today we are going to talk about 5 important words: denominator and numerator, slope, absolute value, even and odd function, and symmetry. In calculus, the term denominator and numerator are often used in the context of differentiation and integration to refer to specific components of a fraction or expression. The denominator typically refers to the bottom part of a fraction of the expression under a radical sign, such as square root. In the context of differentiation and integration, the denominator plays a role in determining whether certain rules or technique can be applied. On the other hand, the denominator refers to the top part of a fraction or an expression. In calculus, the denominator can affect the behavior of a function and how it changes as the input varies. Examples: a sentence, for example, the denominator represents the bottom part of a fraction, indicating the total number of equal parts the whole is divided into, while the denominator is the top part, representing the specific number of those parts that are being considered. Slope. Slope. In calculus, the concept of a slope refers to the rate of change of a function at a specific point. It's measures how quickly the function is changing as you move along its graph. The slope is a fundamental concept in calculus and is closely related to the derivative of a function. Example sentence: in calculus, the slope of a function at a particular point is determined by its derivative, representing the instantaneous rate of change of the function with respect to its input, and describing how rapidly the function output value changes as the input value varies around the point. Next one, absolute value. In calculus, the absolute value function plays a significant role in dealing with the magnitude or distance of a real number from zero on the number line. The absolute value of a number is always non-negative, as it represents the distance between the number and zero, regardless of whether the original number is positive or negative. Example sentence: the absolute value of a number represents its distance from zero on the number line, and it's always non-negative. Even and odd function. In calculus, an even function and odd function are two specific types of functions defined on real numbers that exhibit certain symmetry properties. These properties are related to the behavior of the function with respect to reflection about the origin. For example, the points 0 and 0. Even function is a function fx is considered even if it satisfies the following property: fx equal to f minus f for all x in the domain of f. In other words, a function is even if it remains unchanging when its input is replaced by its negation. Geometrically, the graph of an even function is symmetric with respect to the y-axis. Second, odd function. A function fx is considered odd if it satisfies the following property: fx equal minus f minus x for all x in the domain of f. In this case, the function change sign with its input is replaced by its negation. Geometrically, the graph of an odd function exhibiting rotation symmetry of 180 degrees above the origin. Example sentence: it's important to know that not all the functions are exclusively even or odd. Some functions may have both even and odd components, or they might not have symmetry properties. The concept of even and odd functions are particularly relevant when studying integrals in calculus, as they lead to useful properties when integration over symmetry intervals. Symmetry. In calculus, symmetry refers to a property of a function or geometry object that indicate that they exhibit certain balance or mirror error characteristics. Symmetry is an important concept in calculus and is often used to simplify calculation, solve problems, and gain insight into the behavior of a function under graph. There are several types of symmetry that are commonly discussed in calculus: even symmetry, reflectional symmetry, off symmetry, rotational symmetry of 180 degrees. Example sentence: by leveraging the symmetry of the even function graph, we were able to simplify the integral calculation and efficiently determine the area under the curve. Thank you for your attention. We are ready to take the test in Kahoot.